and gentlemen. We are doing lesson 7. Lesson 7, finding imaginary numbers for the I cycle. So this is something that's a little new to you guys. All right, so we're going to do a little warm up to get you started. I really wish I had you in class for this because I really can get a lot of information on your perfect squares, but we're going to do the best we can here. Okay, so we have radicals. Okay, and it says to simplify the following, leaving your answer in simplest radical form. So I want you to think about perfect squares. So remember, perfect squares is like 1 squared is 1. 1's a perfect square. 2 squared, 4 is a perfect square. 3 squared, 9 is a perfect square, right? 16 is a perfect square. Remember all these bad boys from geometry? You guys did a whole unit on in geometry on this. And I think it was pre-COVID. So I think you had, I think you had the whole unit. I'm pretty darn sure. So all these numbers are perfect squares, okay? All right, so when you go to simplify a radical, you're looking for a perfect square, right? So the square root of 16, it's saying, okay, what times itself is equal to 16? And so since you know 16 is a perfect square, you're just going to say, oh, that's easy, that's 4. Then you get to 32. 32 is not in the list, right? But can 32, is there a factor of 32 that is a perfect square? And you're going to look for the highest factor you can. So the highest factor of 32 that is a perfect square is 16, right? So 4 is, but 4 is not the highest factor that's a perfect square, right? So we know 4 is and we know 16. So I'm going to pick the highest one that can divide into 32. So 16 times 2. So see what I did? I broke them down into their own little radical worlds, I call them. So I said the square root of 16 and square root of 2. We break it apart, okay? When they're broken apart and they're next to each other, it means multiplication. It still equals radical 32. And then I do the square root of 16, which is 4, and there's my answer. Okay, so I want you to take a minute, and I want you to try C, D, and E. Go. Take a minute. Okay, so I'm trying to give you some lag time here. If you need more time, pause it. Okay, I did 75. I broke down into the radical 25 and 3. And the square root of 25 is 5. And then that 5, when I take the square root of 25, it comes out. It multiplies by the 3 that's already out there. And I get 15 radical 3. That radical 3's got to stay inside because it's not a perfect square. Okay. The square root of negative 324, it's a huge number. Believe it or not, that's a perfect square. So the square root of negative 324 is negative 18, because 18 times 18 is 324. Now, you wouldn't know that without a calculator, so you got to use your calculator to manipulate it a little bit. You should have put in, to kind of help you, you can put 324 divided by x. Like if you didn't do the square root of like 324 and you're just trying to find the factors, remember when you do 324 divided by x, it gives you all the factors. So you should look for the list and then you should see when x is 18, y is 18. So then you go, oh, it's perfect square. Okay, 448 I got 64 goes into 448 7 times. So 64 times 7 is 448. Square root of 64 is 8. And I got 8 radical 7. And here we go with a negative. And this is, my friends, what we call the imaginary numbers wheel, or the I cycle that you're going to get into. Okay, so the square root of negative 25. The negative 25 is actually, you've seen it before, we've always said that you can't square root a negative because the square root of a number is a number times itself. And the only way you can have a negative is if you have a negative 5 times a positive 5, right? And that doesn't, it's not a number times itself. They're two totally different numbers. So what we do is when we have a negative underneath the square root, we take out what we call the negative, and we put on the outside an I, which is an imaginary number. You know, I didn't make this up. And then you do the square root of 25 is 5, so then you get 5I times 5, which we like to say is 5I. Okay, so that is what you call imaginary numbers. So it says when you attempt to take the square root of a negative number, the result is called an imaginary number. We assign the expression I to equal the square root of negative 1. So like up here, you could say that I took negative 1 out of that. So it was negative 1, the square root of negative 1 times the square root of 25. By using the imaginary unit I, you can simplify, perform operations, and solve problems that contain imaginary numbers. Okay, so it's a whole new world that I'm opening up for you. Huge. This is a huge world. Okay, so anytime I see a negative underneath the square root now, you got to automatically go, oh, it's an imaginary. Okay, not a real number, not in the real number system, but imaginary. So I'm going to start here. I'm going to do, this is something that a little trick that I always tell kids. I'm like, just do this. Make it a positive, bring an I out. The square root of 144 is 12. I got a 12I. Make it a positive, bring the I out. I've got a 9 and a 3. Okay, keep that I outside. 9 and 3 multiply to be 27. The square root of 9 is 3. And I've got 3I radical 3. Okay, take the I out, make the negative a positive, take the I out, okay? So now it's a 5I, right? Now there's a 5 on the outside, so this is actually a 5I square root of 242, and I don't remember what this is. Oh, 121. I should have known that. 121 is a perfect square, okay? Square root of 121 is 11. So I got 5I times 11 is 55I radical 2. Now, do you notice how I did that? It is, the I is almost like a variable. So like if I had said 5x times 11, you would have said 55x, right? So instead of an x, it's an I. Okay, so think of it, when you go to multiply, it's almost like a variable, all right? It's not really a variable because it means something very significant here, but you get my drift. Okay, so if you remember correctly up here, I said to you, the square root of negative 1 is I, okay? So this is pretty important to understand. It's called the I cycle, all right? If I have, let me come here. So I got I to the first power means that I have one of those, okay? I to the second power means I really have two of those, right? See that? Negative square root of negative 1 and square root of negative 1. I to the third means I have literally 3 square root of negative 1s. And this means I have 4, okay? So And anything to the 0 power is 1. Okay, anything to the 0 power is 1. Anything to the first power is just itself. So that's pretty straightforward, right? Now we start getting into what we call the I cycle. So, okay, I got anything to the 0 power is 1. I to the first is just I. I to the second, now remember, this means there are 2 of these, right? There are 2 square root of negative ones. So if I have a square root and I multiply by itself, doesn't it just come out of the square root? So let me show you an example, and then I'm going to erase it. Let me do it over here. What's the square root of 3 times the square root of 3? Isn't it just 3, right? Because that really means 3 times 3 is 9, and I created a perfect square, and the square root of 9 is 3. Well, when I'm here, I have an I squared, which means the square root of negative 1 times itself. Well, when you multiply something times itself underneath the square root, it should just come out of the square root, which means it's left to be negative 1. Now, I know what you're thinking, because you're like, oh, well, but wait a minute. Negative 1 times negative 1 makes a positive 1, and so that should be equal to positive 1. But we want to recognize that when you take some radical times itself, it truly comes out as what it was originally. And it was originally a negative 1. Okay, so that I squared is equal to negative 1. Then we're going to get into, again, it gets a little fuzzy here. So now we've got a radical times itself we determined was negative 1, right? And then we've got just, so these 2, total negative 1, right? And then we've got just the square root of a negative 1 is an I. So when you see I to the third, you're going to think that's negative I. Okay? Now, do I expect you to remember all this in the red to the side? No. You're going to, I hate to say this, but you're going to have to kind of memorize these, like anything to 0 power is 1, I to the first is I to the second is negative 1, I to the third is negative I, and I'm going to help you. There's just something over to the right here I'm going to help you with. And then I to the fourth is, okay, we got 2 of these. So remember, when you multiply something times itself, it just comes out of the square root, negative 1. Something times itself again, out of the square root is negative 1. And a negative 1 and a negative 1 make a positive 1. So that takes me back to this, doesn't it? And then that actually just goes it cycles right through again. So what we call this the I cycle. Okay? So when you do this, you always start to the 0 power here. Okay? And we go counterclockwise. So I go I to the 0, I to the first, I to the second, I to the third. Okay? And I to the 0 power, anything to the 0 power is 1. Okay? And opposite of 1, I'm going to tell you right off, just to kind of help you remember, is negative 1. Now remember we said it over here. Remember this over here. I to the second is equal to negative 1. And I explained it, like, but you don't really need to memorize, or you have to know exactly that, like, oh, I squared means square root of negative I times square root of negative I, which, oh, Mrs. Risa, it comes out, so it's a negative 1. If you can get down this I cycle, it's going to be key, totally key for you, okay? So notice how I did it again. I did I to the 0, then I came up to the top and did I to the first, then I went around to the next one, I did I to the second, then I did I to the third, and then I'm back here, okay? So I to the first is just I, and opposite of I, which is I to the third, like if you go down, like if you could see my hand, I did I, and then I went down to I to the third, that would be negative I. Okay, so here's 1, opposite of 1 is negative 1, right? There's I, opposite of I is negative I. I realize when I'm doing all these videos how much of a hands person that I am when I'm up at the board, because you guys can't see my hands at the board right now. So I'm trying to be visual about that. So what happens is if I said to you, I wanted I to the 20th, you literally just keep going around the circle, okay? So we're going to do it. I'm going to do it on the next page. So you should never have an exponent on an I greater than 1. So you always have to simplify using this I cycle. So I should always have an answer, like if I have an I to the 15th, I should always end up simplifying that I to the 15th to either I, negative I, 1, or negative 1, okay? So you're going to see it in action. So let's actually do it. All right, so I'm going to have you draw it again, okay? So just to kind of get it down, because you're going to want it on, like on your paper when you go to do these problems. So I gave you a little room here. And let's draw it again. This is people, this is why Mrs. Reese is not, this is why I don't teach geometry right here. I can't draw. I can't draw circles. I can't draw perfect ones. It bothers me. I can't draw perfect ones. Okay, get off that. All right, so we've got I to the 0, right? Remember I said start over there, I to the 0, go up. There's a reason why I'm having you do that too. I to the 1st, I to the 2nd, I to the 3rd. And then this goes back to I to the 4th. Remember I said in the last page, I to the 0 and I to the 4th are the same. Okay, so anything to the 0 power is 1, right? Remember that, anything to the 0 power of 1. Opposite that, so go right directly across from it. I is I to the 2nd, and that's negative 1. Okay, so 1, negative 1. Okay, go to I to the top, I to the 1st, which is on the top. Anything to the 1st, to the I to the 1st is just I, right? That's not going to change. Go right below it, and that's negative I. Okay, you've got to kind of have to have that memorized. It's not really a good answer for you. I hate to say that, but that's how it works. Because what we're going to do, now I'm going to give you steps in a minute, but there's 2 ways to do these problems. So if I say to you, you have to simplify A through E here, which is I to the 7th, I to the 17th, 102, 344, okay? If you have to simplify I to the 7th, okay, you start at the top, okay, because that is I to the 1st power, and then you go counterclockwise around, okay? So you're going to watch the board, and I'm going to do this. I'm going to start here, okay, and I'm going to watch me with the red. I'm going to go I to the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th. So I to the 7th lands right here, which that means it's equivalent to the I to the 3rd, which is negative I. Okay, take a minute. Now I'm going to erase this actually. I'm going to get rid of that red mark. There we go. All right, take a minute and I want you to go on your circle and I want you to count 17 around. Start at I to the 1st and count around. So you should have landed on 5. That work? Okay. Now, you know it's a cycle of 4, right? It keeps going around, and every 4th one, it just goes right back to the original, okay? So here's some steps that you can do, because now we got I to the 102, and that is a lot of counting around. Or I to the 344, come on now, right? We're not doing that. So this is what you're going to do. You're going to divide the exponent by 4, all right? And you're going to look at the remainder only. Look at remainder. I don't care about the number. So like, for example, when I did I to the 17th, I'm going to do 17 divided by 4, right? So when I do 17 divided by 4 on my calculator, I get 4.25, right? I only look right here at the 0.25, okay? And I want you to see that this is like a pie, So if I get 0.25, that gives me, because I'm starting from I to the 0, that gives me here, this is a quarter of the pie. It's the first quarter, so that's the quarter of the pie. See it? Oh, sugar roasted honey nut. I can't get rid of that red now. Anyway, okay, so there's a quarter of the pie. If I get half of the pie, that's going to take me to I squared, right? So it'll take me to 0.5. Because again, let me see if I can do this. I start here and I go around, that's half of the pie, right? So it's 0.5. Let me get rid of this now. Okay, you see the theme now? 0.75 is going to take me to I to the third. That's 0.75 because it's 3/4 of the pie. And then if you don't have a remainder, if the remainder is 0, right, then that is back to I to the fourth or I to the 0. Okay? All right, so do that. Do 102. Do 102 divided by 4. And tell me what you get. What do you get for a remainder? You should get 0.5, right? Which is -1. So that whole thing is equal to -1. It's really messy. I apologize. Okay. Do 344 for me. Should have gone in evenly. So you get 1. No remainder. Okay? So take a minute and do I to the 30th. So do these individually. So now I got I to the 30th minus 3I to the 35 plus 2I to the second. So I to the 30th divide -1. I to the 35. So do 35 divided by 4. And I got a remainder of 0.75. So notice what I did. I'm replacing that. I'm replacing that I to the 35 with -I. And then I to the second, you're going to do a lot, by the way. You're going to see a lot I to the second a ton, is equal to -1. Okay, so notice what I did. I replaced them all, right? So let me come over here with this. So I got -1. -3 times -I is positive 3I. And then 2 times -1 is -2. So I'm going to combine the terms that are alike. I got -3 plus 3I. All right, now what you just did, you don't realize is that's a complex number. Okay, so let's talk about that now. Then we got just a couple more things to do. All right, so when a number contains both a real and an imaginary part, we call it a complex number. All right, these numbers must always be written in what I call A plus BI form. So we just did it up there. This is your A and this is your BI. The A is your real, BI is your imaginary. This means the real part is written first, followed by the imaginary part. So you're going to do some operations with it. We're going to do a lot more tomorrow with them. Well, when we get together, because we're going to do this as a class, the next one, because this is just the intro. I'm going to actually spend some time doing some stuff with you on this. So, but the intro, like for this intro piece, just think about these as when I have these complex numbers and I have to add them, just think about putting together like terms. So when I do that, I go, all right, 3 plus 7 is 10. And then I add the 4's, the i's, the 4i and the -20i. And we've got -16i. So you're just combining like terms. So you combine the real numbers and the imaginaries, and that creates that complex together. For 2, you're going to distribute that negative just like we did in Unit 1. Okay, and combine like terms. Go. Combine that for me. And you should have gotten -4 plus 24i. And 3. Oh boy, here's a box. We're going to do the area model, right? That's what we're going to do. We're going to do 1 and 2i and 1 and 2i. And you're, again, think of this as a variable. Instead of an x, it's an I. So let's go through this. We got 1 times 1 is 1. 2i times 1 is 2i. 2i, 1 times 2i is 2i again. And then 2i times 2i is 4i squared. Now, come back up here to the I cycle. And remember, you have to simplify. You can only have exponents in terms of like I, negative I, 1, or negative 1. You can't have an exponent on an I that's greater than 1. So if you remember, looking above, I to the second power, this is equal to negative 1. So that whole thing really is negative 4. See how that worked? Right, and we're going to put in a plus bi form. So I'm going to do 1 minus 4 is negative 3 plus the 2i, and the 2i is 4i. All right, what do you think of those? Okay, 4. So they're saying evaluate f of x when x is equal to, means that all the x's are now negative 1 plus 2i. So you literally, I love this problem, going to replace every x with negative 1 plus 2i. There's so much good math here. Look at that. You're like, oh my God, Mrs. Reese, you got this, you got this. Okay? So I just want you to evaluate. I don't want you to solve. I want you to find what is the result when I have f of negative 1 plus 2i. It's kind of like saying what's the answer when I have f of 4. Like you replace all the x's with 4s. Okay? You got this. So I'm going to do a squared first, right? Which means I need a box. And I got negative 1 and 2i. Negative 1 and 2i. That means there's 2 of them. And I got 1 minus 2i minus 2i, 4i squared. Oh, there's a 4i squared. There's an I squared. I squared is negative 1. 4 times negative 1. That whole thing is going to be negative 4. All right? Just so happens they're the same. Okay, so I've got, and then I'm going to combine. So I got 1 minus 4 is negative 3. And actually, I don't need parentheses anymore. So I got negative 3 minus 4i. And I'm going to just keep going. I'm going to distribute it. So that was this whole thing like squared. Then I've got negative 2 plus 4i plus 5. And I'm going to combine. So I'm going to get my results here. So f of negative 1 plus 2i is equal to, okay, so let's do it. Combine the numbers first, the real numbers, negative 3 and negative 2 plus 5, that's 0. And then negative 4i and positive 4i is 0 again. So I literally got to leave my answer like that, 0 plus 0i. That's it. I know it sounds funny, but that's how we're going to do it. That's how you have to show it. You always have to show, if it says a plus bi form, you have to show a number, even if that number is 0. It's very different from what you've done before with, like when you have a 0x, you don't put 0x, right? But you have to for the a and the b. Let me ask that. Okay, conjugates. We did a little something with conjugates before. This is just a little reminder. Is a conjugate, remember, is where you take the inside term or the inside value and you change it. Not the outside, just the inside. So see those? Those are conjugates. Okay, so now this one, I'm going to leave this for you to do. You're going to find the product of the conjugate. And when I come around and I check your notes, when you see me next class, I'm going to expect that you have these done. Both of these. These both have to be done. All right, so I want you to do a box method for both, and then I want an answer here. Okay? So that's going to be what's left for you to do. It says, when multiplying conjugates of complex or irrational numbers, a rational number is the product. So that should tell you something about your answer. You should have no more complex numbers. But I want you to do the distributive property for both of those, or the box method, area model, whatever you do. Okay, so you have a homework assignment on this, right? And then the next time we have class, we will be in person. Yay! And we're getting near the end of this. It's coming quick. And I got a couple more lessons, so hopefully you're doing okay with this unit. If you're not, you know where to find me. You know what I say every time. Reach out to me, okay? I would be happy to help. Okay? Talk to you soon.